going to look at another ellipse drawing mechanism, figure 178. From mechanisms for the generation of plane curves. This is Delauney's Ellipsograph. Let me share my screen. So for this one, this is using a pantograph mechanism and driving the one end of the pantograph by a crank. So we're turning a circle, which this little crank up here is going to do, into an ellipse by means of this mechanism. So I'm kind of running out of space here, so let's just shrink my drawing a touch. So there's a couple of sliders put on a horizontal axis here. All these let's make the crank length A, and let's make all these rods here at length B. And then the sliders at a specific length down the rod length C. And it's the same specific length for both. So now we have our mechanism, except this point is here is moving around, so we're put it a specific distance away. From the x-axis, D, that's reasonable enough. So now our mechanism is behaving itself, although our distance D is a little bit too big. The mechanism is not going to do its complete circle, so let's just pull that down a touch. So now we're getting a complete revolution. We don't have anything to drive it by, so I don't know a parameter here. I can actually put it in motion, so let me do that. I'm going to put in an angle. I've got three things selected here. That's the problem. Unselect that, and we can have our angle. There we have our angle theta. Notice theta by default comes in unlocked, so that means we can still animate our. We can still drag our mechanism. We can also animate it just by driving theta locked or unlocked, and watch it do its thing. So the ellipse is going to be traced by point E. Let's just let's selected the second point here. Let's unselect that one, and theta is my parameter. And there is my curve again. We can watch it being drawn. And we can ask for its equation. We confirm that it is indeed an ellipse. And there we have the equation of the ellipse. Now, something that one could do a little bit of algebra on is to work out how we could how to relate these various different distances to the major and minor axes of this ellipse. So I'll leave that for you to think about.